This is semester review, page 4. On page 4, we are going to skip just a little bit. We're going to skip problems number 49. We're also going to skip problem number 51, just because we didn't do problems like these before. Okay, so the first problem we have is problem number 47, and we're going to set up a system of equations. So we have a vendor who sold 200 tickets for an upcoming rock concert. Floor seats were $30, so I'm going to write $30 for floor seats. Stadium seats were $24, so I'm going to write $24 for stadium seats. And I think I'm going to use X because S gets so confusing. And so $30 and $24, and so since we've been dealing with dollars, we need to equal a dollar amount. So the vendor sold $6,080 in tickets. Now before we even get started with this problem, I can tell you I've worked it before, and it gives us a really bad answer. It doesn't work correctly. That's because a lot of times when we make a review, we just pick some numbers to fit into a similar problem that goes with the test, and in this case the numbers just didn't work. So I'm going to work through it anyway and show you how to go through the process. So when you have your money all goes together, and then the non-money part, the floor tickets and the stadium tickets, give you 200 seats. So this is a system of equations. We're going to solve this with elimination. I'm going to multiply the bottom equation by -24. So I'm going to have 30F plus 24X equals 6080. That one didn't change at all. But the second equation will be -24F minus 24X equals -4800. Alright, 24X's are going to cancel. 30 minus 24 is 6F equals 1,280. When you divide by 6, here's where the problem becomes. You get 2 and 1 and 3, and it's like 0.3, so we would round it to just be 213. But if I sold 213 floor seats, is that reasonable, considering that I only sold 200 tickets total? So in this case, this problem is not a good problem. The floor seat turned out to be 213. So if I plugged that back in right here, then the X would have to be -13 for it to work. And of course that's a bad answer. So if you did have something like this, you would say that's not reasonable. Number 48, we have a baker with a wedding cake. Not this baker because she doesn't bake. But we have 0.6 x squared minus 12x plus 150. And so they're telling us that y is the cost. Y is our cost. So our cost is 0.6 x squared minus 12x plus 150. So what's the minimum cost? Well, anytime you see minimums or maximums, it's always the vertex of the quadratic. So the vertex here, we'll use our formula, x equals -b divided by 2a. So I'm going to have -12, which makes that be +12, divided by 2 times a, which is 0.6. So that gives me 12 divided by 1.2, which happens to be 10. And that's not too bad. 10's not a bad number to plug in. So going back to my y equation, I'm going to have 0.6 times 10 squared minus 12 times 10 plus 150. So that's going to be 0.6 times 100 minus 120 plus 150. So that's going to be equal to 60 minus 120 plus 150. And so that ends up to be 90. And we were trying to find the cost, and we know our y value is the cost, so our y value is going to be $90. We are skipping number 49, so I'm going to go to 50 now. We have 8 classmates that want to share a cake. The cake makes a rectangle. It's going to be 4 pieces by 6 pieces, so that's going to be a total of 24 pieces. If we have 8 classmates, we divide evenly by 8, and each person's going to get 3 pieces of cake apiece, which is a nice amount of cake, probably too much cake. But that's all. That's all you have to do. 51 we're going to skip. 52. 51's not a difficult problem. We're just skipping it because we didn't do a problem like this previously in the semester. Number 52, we drove 115 miles to grandmother's house on Friday. On Sunday we drove back, which means we went another 115 miles. The round trip travel time was 4 hours. So if you use distance equals rate times time, my distance is 230. My rate, I don't know, but my time is 4. So I'm going to divide by 4 on both sides. And I'm going to get, let's see, 5 and 8. Wait, sorry. 5 and 7.5. So the rate was 57.5 miles per hour, which is really slow if you're on a highway. But if your grandmother, for some reason, lives in town and it takes you 115 miles to get there, then maybe that would be reasonable. Alright, number 53. We're going to be graphing a system of equations. The first thing I'm going to do for each of my equations is get y by itself. So for the top graph, I'm going to subtract x from both sides and have y equals 5 minus x. For the bottom graph, I'm going to subtract 3x from both sides and have negative y equals negative 3x minus 2. Divide by negative 1, divide by negative 1. And the red graph is going to be 3x plus 2. Keep in mind, on the red one, here's my m, here's my b. On the green one, your m is always in front of x, so my m here is negative 1, whereas my b is 5. So, if I graph these two equations, okay, and it's not going to be pretty because I don't have a grid. But if I do graph these two equations, my y-intercept for the green is 5. My slope is negative 1, so I'm going to go down 1 over 1. Down 1 over 1. If I can get my little drawy thing to work. Connect those dots. Get close to connecting those dots, I guess. I didn't do a very good job. There's the green line. The red one is going to start at a y-intercept of 2, and the slope is going to be 3, so I'm going to go up 1, 2, 3 over 1. I don't know why this is so hard to make these dots on here, but for some reason it is. So when I connect this, the best estimate I get is that this looks like, right there is my intersection. So it looks like my x is 1/2 and my y is 1, 2, 3, 4. So that's my estimation. And you have a grid, hopefully, that you're working on, so maybe your estimation will be better than my estimation. Alright, next we have problem number 54, which it looks like I've already worked. Okay, for problem number 54, my green graph is y is greater than or equal to 3. So I go to 3 on the y and the greater than shades above. And then for the next graph, x is less than or equal to 4, so I go to 4 on the x-axis right here. And it's solid, and I'm shading less than, so I go left. And then this pretty green and red Christmassy colors area is where your solution is going to be. Okay, let's clear this. Number 55. For number 55, we are going to be graphing quadratics. And one of them is pretty easy to graph. The other one we have to be rather clever to get it to work. Okay, so again, this is going to be my green graph, and this is going to be my red graph. So I'm going to make a grid to the best of my ability, which may not be much. Starting with the green graph, I know that this is a parent function that's been shifted up 1, 2, 3, 4 places. And it has a slope of -1. So I go down 1 over 1 and down 1 over 1 the other direction. And then I connect these dots to make a U. It's less than, so I'm going to shade below the vertex, right here. The red graph, I have to find my vertex. So x is going to be -b divided by 2a, so -3 divided by 2 times 1, which is -1.5. And the y value for that is going to be 2.25 minus 4.5 plus 2 when you plug it into the calculator. So the y value is going to just be 0.25. Actually, that's a negative 0.25. So I would have 4.25 minus 4.5, so I have -0.25. So if my x is at 1.5 and my y is at -0.25, then I'm really given an estimate right there. But luckily we do know the slope is about 1, so we're just going to go up 1 unit over 1 unit in each direction. So halfway there, and I'm going to connect these dots. And this one is greater than, so we're going to shade above. So where do they overlap? Right here in this little section is where the overlapping is. So I'm coloring it in purple so that you can be sure and see it. That's what my solution would be. Alright, last problem of the review, and then you're going to be ready to ace this exam. Oh, by the way, did I tell you that you can use this review on the exam? That'll probably help you a lot. Alright, so for number 56, the first thing we need to do is get y by itself. So I'm going to subtract x. So -7y is greater than -x minus 14. And so I've thrown in a little trick here. If you divide by a negative number, not y, just 7. If you divide by a negative number, what happens to your symbol? It changes direction. So now y is less than -1x divided by -7. Those are going to both be positive. Minus 14 over -7 is plus 2. You probably can hear my dog in the background rolling around. She's having a lovely time. So, this is not squared. Notice that there's not, it's not x squared. It's just x. So that means this is a line. So when I graph this, all I have to do is start at my y-intercept, which is 2, and do my slope, which is 1/7. So I'm going to start at 2 and put my dot. My slope is up 1 over 1, 2, 3, 4, 5, 6, 7. This is going to be a very shallow line. But now, it's less than, it's not equal to. So to the best of my ability, I'm going to make a dotted line when I dot it out. That's hideous, but I'm sorry. Okay, and it's less than. Less than means shade below. So there's my shading below. And that's it. That's all she wrote, folks.